Alright, our next quadrilateral that we are going to talk about is the rectangle. So this video is going to cover rectangles and squares. And we're going to start with the rectangle properties. So let's draw us a little rectangle here. And there's going to be three main properties of the rectangle. Now the first one, we are going to take a look at the last quadrilateral we talked about, which was a parallelogram. So if you remember in a parallelogram, there were 5 properties. The first one was that opposite sides are parallel. And if you look here, they are parallel, we are good to go. Are opposite sides congruent? Yes, opposite sides are congruent, so that one still follows, and we'll mark those with our 2 slashes on either side. The other property is that opposite angles are equal. So in this case, are the opposite angles equal? And yes, they are, because specifically, what do you know about all the corners in a rectangle? Hopefully you know from the past that all angles are 90 degrees. So I'm going to put that here because I'm going to fill in step 1 in a second. So all angles equal 90 degrees. And then, what else do we have from a parallelogram? We have that the angles that are next to each other or same side equal 180. And so that's true because 90 plus 90 is still 180. And then we have diagonals bisect. So if I do this, this is true, the diagonals do bisect. So that means that all properties of parallelograms are the same for rectangles. So all same as parallelogram will be first. And I'm going to abbreviate that. Parallel. So the first step is all the same as parallelograms. The second step, or the second property, is all angles equal 90. Now the last one has to deal with the diagonals. So if you look real close at the diagonals, you'll notice that both of these, see, I marked with the same. So that means that all 4 of these segments are equal in the middle. So if that's true, that means that the holes are also equal. So then that means that the diagonals are also congruent. So the diagonals are congruent. Okay, so now we're going to take a look at some pictures. I got 2 examples for you of how you might see something different than what you've already seen. Alright, so let's take a look at example 1. I'm going to go ahead and draw a rectangle for us. And one of the things that they're going to expect that you know how to do is that if you have a rectangle with both diagonals drawn, I can give you any angle up in here. So I'm going to go ahead and label these with numbers. So we'll go 1, 2, 3, 4 down here in the bottom, 5, 6, 7, 8, and we'll go 9, 10, 11, 12. So with all of these, I should be able to give you one of these measurements, and you should be able to find all the rest of them. So let's start down here in the corner at angle 10, and I'm going to name angle 10 at being 50 degrees. So the first thing that I would think about is, what do you know about a rectangle? So remember, the second property was that all of the corners are equal to 90. So that means if 50 is here, look what we have. We have something, if you recall, complementary. 2 angles equal 90 degrees. So if angle 10 is 50 degrees, then angle 9 has to be 40 degrees, because you have this equaling 90. Okay, now, if you remember, all the diagonals also bisect. So I'm going to throw these in here. So what kind of triangle do I have if I just highlight this one right here? What kind of triangle is that? Hopefully you're saying to yourself, that's an isosceles, because I have 2 congruent sides. So if these 2 sides are congruent, that means that these 2 angles are also congruent. So the other angle here is going to be 50, which then that means I can fill in all these outside angles, because that means 12 has to be 40, because again this has to equal 90, and then 2 has to be 40, because isosceles, and then 1 has to be 50, 3 would be 50, and 4 would be 40. So that's pretty easy to fill in the outside. Now how am I going to get these inside angles? Hopefully you're thinking to yourself, these triangles equal 180. So that's another blast from the past. So over in the triangle on the right, if this is 50 and 50, that means if I do 50 plus 50, I get 100. And so 100 minus 180 is going to give me 80. So my angle 8 will be 80, and then vertical means that angle 6 is 80. And now how am I going to get 5 and 7? I could do the same thing. 40 plus 40 is 80. Subtract from 180, and I have 100 on either side. So that's one thing that you're going to be expected to know how to do. Another thing might be how to set up some equations. Now, most of these equations we have done before, and we've done this one as well, but I want to give you just a little refresher and also go over how to kind of put in the information into the diagram, because sometimes what we are doing is we are not knowing how to put this information in. So, let's say that I am given that angle LSP is equal to x plus 3, and angle PSA is equal to 4x plus 2. So let's go ahead and let's highlight these, because I think that's what we don't know is where this information goes. So I have LSP as my first piece of information. So what that means, remember, you're only looking at where the middle letter is. So that middle letter is right here. So that means that this piece of information, x plus 3, goes right here and represents this part of the angle. Now the other one is PSA, so I'm going to highlight that in purple. PSA is right here, and where's the middle of that? Again, it's at S, but it's this portion, because if you highlight it, you can see PSA, it's this corner. So this corner is 4x plus 2. So we need to figure out how are we going to set up an equation to find x. Again, you've done this before, and what do you know about the corner of a triangle? The corner of a triangle equals 90. So I'm going to add these together, and I'm going to set them equal to 90. Part plus part equals 90. So x plus 4x is 5x, and 3 plus 2 is 5. I'll subtract my 5. I get 85 equals 5x. Divide by 5, and I get x equals 17. You can double check your work. Sometimes they ask you. You can plug her back in. And if you plug this in, 17 plus 3 gives you 20. 17 times 4 is 68, plus 2 gives you 70. So that is a complementary angle because 20 plus 70 is 90. Alright, let's move on to squares. So squares really only have one way that you could fill in their diagram. So these are actually pretty easy. They're my favorite ones because it's just one and done. You know exactly what to do. So squares, again, their properties, we're going to go with 3 again. And I'll go ahead and give you a hint to save us time. They have all the same properties as the rectangle. All same as rectangle. So all of the ones that we said before also work for a square. There are 2 defining ones that make them absolutely different. Let's see if you can figure out one of them. One of them is that all the sides are equal. So not just opposites, but all sides are congruent. The other one is that right here in the middle of the square, something very special happens. So in the middle of the square, not only are the diagonals equal to each other, and they do cut each other in half, but they also are perpendicular. So do you remember what perpendicular means? If I were to write this, diagonals are perpendicular with that sign, that means that they're 90 degrees. So that means that there are 4 boxes all on the inside because all of them are equal to 90. And then because these are isosceles triangles, because all these are equal, that means that these have to be cut in half along the baseline. So that means that these, if you cut 90 in half, are 45 all the way around. So this is the basic skeleton for every square. They will never change. So that'll be pretty easy to set up formulas or equations if you get them. Alright, last but not least is area. Now I know that you know what area is for a rectangle and a square. I'm sure you've been doing this since you were, little, grade school, middle school, whatever. So just so we understand that the area for a rectangle is length times width. That's supposed to be a C. So if you have a nice good old-fashioned rectangle and you're given like an 8 and a 5, you would just do 8 times 5 would give you 40, and that would be what measures on the inside of this bad boy. Now a square, you can do the exact same thing. The only difference is that sometimes you may see, because in a square, since all of them are equal all the way around, they're only going to give you one value. So let's say that they give you a 10 here. You need to know that these tick marks mean they're equal all the way around, and so length times width is the same. And so they will use the formula s squared, because 10 times 10, length times width, is just squaring itself, and that's 100. So now you are prepared for your homework or your classwork, and so you can go ahead and get your worksheet to get started.